this is, as I said, a very important result. So what needs to be understood here is the following. As long as these are all the same and this is 0, the limit will always be what do you think?
1.
Yes, yes, yes. So let me give you a couple of examples before we choose from the book, or just at least one example. So let's say I have limit as x approaches 4, and I have sine x minus 4 over 2 x minus 4. So this condition is fulfilled. This condition is fulfilled. But I need this box or whatever rectangle to approach 0. Yes. Yes, of course. When I move one term from one side to the other, and I do have the whole thing. So this is the same with this is the same, and this is the same. This is the same, this is the same, this is the same. What is the answer?
Through 2.
2.
Excellent. That's it. Exactly. So sometimes certain manipulations, algebraic manipulations, or manipulating the function may be required. So now we open the floor to discussions. So anything you want from 45 through 60, anything. Anything you like to choose, we're practicing these limits. When we can apply L'Hopital's rule, we will. But we're not fully equipped yet. We need to move on to 3.4, and then we will always be able to apply L'Hopital's rule. But we don't have all the information yet. So, anyone would like to choose? Okay, I will choose 47 before you choose the next one. In 47, I see limit as t approaches 0, sine 3t over sine t. So remember last time we had that algebraic manipulation, so to speak, a very simple thing, going back and forth. Those who are not in class last time, please, I'm begging you to watch the videos and look at the examples that we did in class. It's a lot. So we said that this, as long as there is one term, can be split into these 3 fractions and going backwards. Something like that, a little algebraic manipulation will be required in this case. So you can say, yeah, it's 0 over 0, but at this point we cannot use L'Hopital's rule. So initial assessment is fine, we have to do that. But now here's how I'm going to present this function so it makes sense. The numerator over 1 and 1 over the denominator. You can say, wait a minute, what are you doing? Nothing. This is convenient. This times 1 is this, 1 times this is this. I didn't do anything. But now, if I realize that this is an option, a very good one, then I'm going to do this. This is sine 3, sine 3t. Well, I need 3t in the denominator. But if I put 3t in the denominator, I have to put it in the numerator. I cannot all of a sudden divide by 3t because I want to. No. But if I multiply by 3t and divide by 3t, nothing happened. Because this is 1. I will repeat the process for sine t. So I need a t. But if I multiply the top by t, I have to multiply the denominator by t. I cannot just say, oh, I need a t up there. No. Multiplying top and bottom means multiplying by 1, no change. Also, I have to realize that when t approaches 0, 3t also approaches 0. Because if I multiply here both sides by 3, this is what I get. So now I have a product of two different functions. This one has the rectangle, the rectangle, the rectangle. Where is this going to? One, two, three.
Going to 3t.
Yes, leave that alone. We haven't talked about that. Only this. So I have the 3t.
And going to 1.
Yes, I have the 3t, and I have the 3t. This is required. 3t, 3t, 3t to get the 1. Awesome. You're way ahead of me. That's awesome. So this is gone. See my props. Now, where is this going? T, T, I didn't mean that. I did not mean to include the t in the denominator. Okay. T, T, T. Where is this going? T
It's going to 1.
to 1. Good. So these are gone. What is left? A 3t in the numerator and a t in the denominator. So what is the answer?
3.
Yes. The answer is 3. We can come back to this problem after we look at section 3.4, and of course it will be much easier. Okay, let me know, I'm on page 7, let me know if you want to pick anything else. So this was a very good example of how to manipulate a function without changing it and get what we are interested in. So let's see if you want to choose anything else. Okay, I will choose 51. Did you make up your mind? I can write it next to it. Do you have a pick or not yet?
$56.
56, very good. Okay, we'll get to 56 in a minute. I would also like to look at 59. Anything else? Yeah, why not? Let's also look at 60. I think it's plenty. Perfect. So we don't know how to differentiate tangent to x yet. We will in half an hour. So yes, we do have 0 over 0 because tangent 0 is 0 and x is 0. So what I'm going to do, of course, I'm going to change this into 1 over x for now, times tangent, which is sine 2x over cosine 2x. So I put 1 over x in front, and then I have times tangent 2x, which is this. And at this point, I see already that this is no threat. No threat whatsoever. Why? Where is this going when x approaches 0?
Is that 2?
0.
Cosine 0, right? 2 times 0 is 0. Cosine 0 is 1. No threat. If I put 0 here, it's a big problem. I can't have 0 in the denominator, right? So remember, cosine 0 is never a threat because it's 1. So what I'm dealing with is this. No problem. I multiply the numerator by 2. I multiply the denominator by 2. And I also realize that if I multiply this, both sides by 2, I got exactly what I wanted. So limit as 2x approaches 0 from sine 2x over 2x. What will this equal to?
1.
Exactly. So finally, what is the limit?
It's going to be 2.
It's exactly 2. 2 times 1 over 1. This is all algebra, basically. We didn't even differentiate. We just remember that the limit, when all these three are the same, this one has to be in the numerator, this has to be in the denominator, or vice versa. Not both in the numerator. No, no, no. One in the numerator, one in the denominator, and then 2x approaches 0. We chose 56. So 56. Limit as x approaches 0 from cosecant x times sine applied to sine x. Interesting. Very good. So now when x approaches 0, where is, so piece by piece we have to understand what's happening here. So I'm going to start from the inner. This is a product. So this is the inner, this is the outer, and then multiplied by cosecant x. We'll get to that. Where is sine x going to? When x approaches 0.
Is it 1?
That's cosine. So
0.
yes, sine and cosine cannot be 0 at 0. Both, right? Cosine is 0, then sine, cosine is 1, sine is 0. Perfect. Now I need to determine sine 0 again. Where is this going? When this approaches 0, sine 0 approaches
0.
Of course, it's the same thing. Good. Now let's discuss cosecant. Because cosecant, if you remember, this is 1 over sine x. We have to remember that. Cosecant is 1 over sine x. If it starts with c, is 1 over s. If it starts with s, is 1 over c, cosine. If it's secant, is 1 over cosine. If it's cosecant, is 1 over sine. Okay. So where is this going? Okay, I asked the same thing 3 times, so this must be 0. So we're looking at a situation of 0 over 0. So there is hope. I will rewrite the function. How do I rewrite it? Exactly how you see it here. So this is limit as x approaches 0 from sine of sine x divided by sine x. And now remember, when x approaches 0, yes, I asked you 3 times, sine x approaches 0 as well. So now, what is the limit?
Quantity 1.
Exactly 1. Exactly 1. It's just the pattern that we are discussing. Limit as the quantity approaches 0 from sign of the quantity divided by the quantity. We don't care what the quantity is, as long as it approaches 0, and these are the same, identical, not 2 or 3, whatever, right? They have to be identical, then the answer is 1. Very good pick. Any questions?